Welcome back. Today we're going to do 5.1 angles in radian measure day 4, and we're going to apply what we've been learning so far. We're going to start off with how to find or how to use the radian measure to find the length of an arc of a circle. So here we have our circle. And here is our central angle. A theta. Let's try that again. Okay. And this is R. And here's S, which is our arc length. So in order to find S, we do R, which is your radius, times theta, which is the measure of your central angle. And very important, this angle is a radian measure. So if they give it to you in degrees, you're going to have to convert that to radians. And just to recap, you're going to have to do the degree times pi radians over 180. Okay? And then we know that R is your radius. So with this example, it says a circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. So in our formula, remember, it's S equals R times theta. We have our radius and our central angle. However, this formula can only be used when theta is expressed in radians. So we have to first convert 120 degrees to radians. And if you remember how to do that, we just multiply 120 by our conversion factor. And the degrees will cancel. And we get 120 pi over 180 radians, which is 2 pi over 3 radians. Now we can use the formula. So we got our radius, which is 10 inches, multiplied by our central angle. And then from here, you simplify it. So that'll be 20 pi over 3 inches. And sometimes they're going to want the exact, or they may ask you for the rounded. So if they say exact, that's the exact answer. And then, of course, this is the rounded. And for the checkpoint, a circle has a radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. Express arc length in terms of pi, then round your answer to 2 decimals. So basically, they want you to do the same thing. Give the answer as an exact answer. That's what it means by in terms of pi, and then a rounded answer. So I'm going to give you a chance to try it, and then we'll go over it. And as you can see, I changed the 45 degrees to radians, so it was 5/4 radians. And I plugged that in my formula for my central angle, multiplied it by 6 inches, and I simplified it and got 3 pi/2 inches, which is approximately 4.71 inches. Okay, now we're going to move to application problems, and we'll start off with linear and angular speed. And these two, so we have linear speed and then we have what is called angular speed. And we use these type of speeds to describe motion on a circular path, such as a carousel, that you see at most fairs, the ones that have the rows of animals. So the linear speed is represented by V equals S over T. And T represents your time. And we remember that S represented the length of the arc. And remember, if you don't have S, I'll just put this down here. You can always find it by doing R times theta in radians. So if you wanted to rewrite that, that's how to look. And then we have what we call angular speed. And we use this symbol. It's like a W, but it's omega. And we have our central angle again in radians divided by our time. And here again, if you don't have theta, you can find it by doing S over R. So if you wanted to rewrite that, you would have to do S over R first, whatever that is, divided by T. And then if we wanted to do linear speed in terms of angular speed and put the relationship together, we would get something like this. Where omega is the angular speed, and we can derive this formula. So your radius times your central angle, which is in radians, divided by your time. Okay, so now we're going to do some practice with finding the length of the arc. So let's say they gave us the radius was 16 inches And our central angle is 60 degrees. Well, we have to make sure we change this to radians. And as you guys work more with these problems, you're going to be able to change these degrees to radians faster, because you're going to notice that they are the common ones on our unit circle. But until then, I'll just show my work. And you get here, and you reduce it, and you'll get pi over 3 radians. Now, use our formula. And you're going to plug in your radius and your central angle. And you'll get 16 pi over 3 inches. And then if they want you to give the approximate answer, of course you would just put that in your calculator. And usually they'll say 2 decimals. So that would be approximately 16.76 inches. And then if you want to try another one, we'll do the radius of 9 yards. And our central angle is 315 degrees. And I'll let you try this on your own. And there you have it. Changing 315 degrees to radians, you'll get 7 pi over 4. And then plugging that into your formula for your central angle, you're going to multiply that by your radius, which is 9 yards. And so the answer in terms of pi will be 63 pi over 4 yards. And the approximate answer will be 49.48 yards. And don't forget to box or circle your answer. What I did was develop some application problems, helpful hints, because most of this section, the practice problems, deal with word problems. So to help you all out, I came up with these helpful hints so you'll know when you should use which formulas and what you should do to make sure that you're answering the right question. Make sure if you see angular speed, let me see if I can use this laser. Okay, this is your angular speed. This is always measured in revolutions per unit of time. So angular speed is in revolutions. And just remember that 1 revolution is 2 pi radians. Arc length, this is the formula, S equals R times theta, which is your central angle. Make sure that you convert that or those degrees to radians. And then arc length in a word problem, they may ask you for arc length, and then sometimes they'll use distance around a circular object. For example, they may say hands on the clock, or how far did the minute hand move, or how far did the second hand move. Then you know that they're really asking you to find the arc length. And then linear speed, we use V equals S over T. And if you notice, this R times theta comes from your arc length, and that's always divided by your time, or your unit of time. And sometimes they'll give this theta over T in terms of your angular speed. So theta over T and omega all represent angular speed. And just make sure If this is the case, then you want to convert your revolutions to radians by multiplying the number of revolutions by 2 pi. And I think that should be enough to get you through those word problems. And if not, we will always review and go over it before starting the next lesson.